Okay, welcome to Common Core Algebra 2, January 2017, parts 2s, 3s, and 4s. IC1 minus IQ. First of all A plus BI4 means is that you're going to see an I in your answer. So to cube something, I'm going to multiply it by itself 3 times. I can't really do that, but what I can do is multiply it by itself 2 times. Now, as much as I love you guys doing square binomial theorem, most of my students prefer using a box. So I have 1 minus I, 1 minus I, 1 minus 1I, minus 1I, positive I squared. I have 1 minus 2I plus I squared. And then the most important thing for this type of question is that I squared is negative 1. So I replace the I squared with negative 1. When I combine like terms, the negative 1 and positive 1 cancel. I'm left with negative 2I. So now I do negative 2I times 1 minus I. I distribute. I get negative 2I plus 2I squared. But again, whenever I see an I squared, I replace with negative 1. My answer becomes negative 2 minus 2I. Not bad. So what do we get next? An orange juice processing plant receives a truckload of oranges. Anything mathematical there? Not really. The quality control team randomly chooses 3 pails of oranges, each containing 50 oranges, from the truckload. Identify the sample and the population. The population is the total people or oranges or whatever's involved. The population is the truckload of oranges. From that truckload of oranges, or should I say oranges, they chose a sample to test. The sample was the 3 pails of 50 oranges. State one conclusion that the quality control team could make about the population if 5% of the sample was found to be unsatisfactory. If 5% of the sample is unsatisfactory, if it was randomly selected, then approximately 5% of the population is unsatisfactory. That's why we choose a sample. That the sample statistic will lead to a population characteristic. All right, what do we got next? Unit circle, everybody's favorite. The one thing you need to know with the unit circle is at any point on the unit circle is cosine of theta, comma, sine of theta. So, there's no math here to explain why. Well, you need to also know that cosecant of theta is the reciprocal of sine. Those are the 2 concepts you have to know. So, y is cosecant theta 1 over y. Sine of theta is the y value on the unit circle. And cosecant theta is the reciprocal of sine. I don't know what they're going to ask in the unit circle, but they're probably going to ask something. Understand that any coordinate x comma y is cosine of theta comma sine of theta. It gives you a function. I see a value in front, I see an e, I see an exponent. This is a variation of curve. The rate is what's in front of the t. So the rate is this ln of 1/2 over 1590. So if it wants to know if it's growth or decay, if this is positive, positive rate, then it's growth. If it's a negative rate, then it's decay. So I'm going to put this crazy thing into the calculator and see if it's positive or negative. Ln 1/2 over 1590. Where's my calculator? Alpha y equals enter. Ln of 1/2 over 1590 is negative. If it's negative, so it's negative 4.359. That E means times 10 to the negative. That's scientific notation. Times 10 to the negative 4. That is decay. Because the rate is on the grid below, sketch a cubic polynomial whose zeros are 1, 3, and negative 2. All right, let's get a grid here. That's a very good job I just did there. Very proud of that. This one's a little funky. Of course, on your test, use a straight edge, so that's really funky. Ew. Ew. It's okay. All right, my zeros are 1, 3, and negative 2. It wants a cubic polynomial. So, here you go. My board's not really well calibrated right now. Really sloppy, but that's it. Could you have done a negative leading coefficient? Sure. It doesn't specify. Either of those are fine. These 2-point questions are pretty nice. Radicals are fractional exponents. I'm going to rewrite the radical as a fractional exponent. It's the power over the root. Now that I have that, it wants me to solve for what? Well, to get rid of a constant exponent, I raise both sides to the reciprocal power. Y equals, when I raise the power to a power, I multiply the powers. That would be 30 over 15. Which is, look at the humor, 5 times 6, that's 3, 6 over 5, 6 over 5, yeah, 30 over 15, which is y equals x. Okay. Are the events student is male and student prefers reality series independent of each other? Well, there's 2 ways to check for independence. P of A and B equals P of A times P of B, or P of A equals P of A given that B. So do I have my totals? Yes. I'm going to have the A, that's A be male. I'm going to have B be reality. So I'll do both of them. Male and reality would be 70 over 490. There's no conditions in this formula, so the total is always your denominator. P of A, what's the probability someone's male? 230 over 490 times what's the probability someone likes reality? 180 over 490. Let's do the other piece, and then we'll see if they're equal. P of A, probability of male, again, is 230 over 490. Probability someone's male given that they like reality. I'm going to circle my reality. Out of those 180 people that like reality shows, how many are male? 70. Now I'm going to use my calculator to see if these are the same. I'm going to use my personal calculator, so I'm pulling the other one up. 70 over 490 is 0.1428. The other side, 230 over 490 times 180 over 490 is 0.1724. So no, they're not equal, they're not independent. My other side, 230 over 490 gives me 0.4693. My 70 over 180 is 0.38 repeated. No, they're not equal, not independent. You might be thinking, well, will ever one formula give me dependent and the other one give me independent? No, they'll both give you dependent or they'll both give you independent. It's two different ways. Pick one you're more comfortable with, go from there. If they don't give you a two-way table, make a two-way table. It wants me to do f of x over g of x. So I'm going to divide 3x squared plus 7x minus 20 by x minus 2. To divide polynomials, we divide, then multiply, then subtract, then bring down. And when you're subtracting, don't forget to keep change. So I'm dividing 3x squared by x. That's going to be 3x. Line the terms up. The x goes over the x here. Then I multiply 3x times each of those. 3x squared minus 6x. Subtract. Keep, change. Those cancel. I have 13x minus 20. Now repeat the cycle. Divide. Divide 13x by x. That's 13. Multiply 13x minus 26. Subtract. Keep, change. Cancels. I'm left with 6. That's my remainder. So I put my quotient, 3x plus 13, plus 6 over x minus 2. Make sure you put your remainder over your divide. That's what this means right here. There's a couple different ways to do 33. It looks kind of scary. What I see here, I see that this, I divided the x minus 4 by. So that's what I did. I started with 2x to the third minus 10x squared plus 11x minus 7 divided by x minus 4. Again, divide. When I divide these, I get 2x squared. Multiply 2x to the third minus 8x squared. Subtract. Keep, change. Bring down. Next cycle. Divide. Negative 2x squared divided by x is negative 2x. Multiply. Negative 2x squared plus 8x. Subtract. Keep, change. Bring down. Divide. 3x divided by x is 3. Multiply. 3x minus 12. Subtract. Keep, change. And I have my remainder. So I have plus 5 over x minus 4. So let's now see where I'm at. I'm going to just kind of erase all this to see where I'm at. So I have My left-hand side now is 2x squared minus 2x plus 3 plus 5 over x minus 4. And my right-hand side is x minus 4, 2x squared plus hx plus 3 plus k. So notice my right-hand side does not have a fraction. So to get rid of this fraction, I'm going to multiply everything by the LCD. X minus 4, x minus 4, x minus 4, x minus 4. So I have 2x squared, x minus 4, minus 2x, x minus 4, plus 3, x minus 4, plus 5 equals x minus 4, 2x squared, plus hx plus 3, we'll have a space here, plus k. So, because I have an x minus 4 in all these terms, I can just factor that out. And I can have x minus 4 times 2x squared minus 2x plus 3 plus 5. Well, looks pretty much like what I have here. At this point, I'm done. The h is the -2, and the k is the 5. This is a lot of algebra. It's pretty complex. There's probably other ways to do it. We could probably have extended the right-hand side and see what you got. But there's, again, different ways to do this problem. It's just a nice, good old Algebra 2 problem. This one is a lot nicer. Elena has decided to run the Buffalo Half Marathon in May. Good for her. I'm going to move on. She researched training plans on the internet and is looking at 2 possible plans. Jillian's 12-week plan and Josh's 14-week plan. Fantastic. Good for her. I'm moving on. The number of miles run per week for each plan is plotted below. Okay, I see my graph. Which one of the plans follows an arithmetic pattern? Well, arithmetic is linear. Which one is linear? The dots, which is Jillian's plan. Explain how you arrived at your answer. Jillian's plan is linear. Is arithmetic. Because the graph is linear. Then it says to write a recursive definition to represent the number of miles run each week during the plan. So, recursive, A1 equals, AN equals, AN minus 1. After the first week, she is at 10, so A1 is 10, and each week she is going up by 1 mile, so I put 1. Writing recursive definition or recursive formula should be simple. Now, when the reading comprehension comes back in, Jillian's plan is an alternative if Elena wants to train instead for a full 26-mile marathon. I don't care what she's training for. I don't know if you do. I do care that I froze again, so give me a moment. And we're back. So I don't care what she's training for, but I do care that week 1 would start at 13 miles and follow the same pattern. So now, A1 is going to be 13. The common difference is still going to be 1. Write an explicit formula. Well, your explicit is AN equals A1 plus N minus 1D. I don't take up a lot of space, so I'm going to erase all of this stuff. Yeah. So, AN equals 13 plus N minus 1 times 1. It's the simplest form, so I'm guessing it wants me to get rid of the parentheses. And then combine like terms. and that's it. I think it was a very, very simple 4-point question. I hope students are able to rack up all the points on here. As long as you know how to write a recursive and an explicit definition, you're good. The explicit's on your reference sheet, and of course the recursive, check out my playlist. The guidance department has reported that of the senior class, 2.3% are members of Key Club, 8.6% are enrolled in AP Physics, 1.9% are in both. At this point, I want to make a two-way table to deal with this data. The two things I'm looking at here are Key Club and AP Physics. So I'm going to do Key Club and no Key Club. I'm going to do AP and no AP. Do you have to do a two-way table for this? Well, you don't have to, but I definitely encourage my students to. It makes everything much easier. And of course, in a two-way table, I need to include my totals. Because these are percentages, I'm going to make it out of 100. 2.3% are in Key Club. That's the total percent in Key Club. 8.6 are in AP Physics. That's the total in AP Physics. 1.9 are both. This cell right here is both Key Club and AP Physics. Now, at this point, I can fill in the missing values by subtracting. This here is going to be 97.7, 91.4, 6.7, 0.4, and 91. Determine the probability of P given K. So it wants P given K. So the condition comes after the slash. The condition is Key Club. So I circle the row or column as Key Club, and I'm only using those values. So out of the 2.3, 1.9 are in AP Physics. It wants that as a percent, so I'm going to go to my personal calculator here. I'm going to divide them and multiply it by 100 to make it into a percent, and I get 82.6%. Up to here. For conditional probability, circle the row or column you're working with, and makes it much easier for you. The principal would like a basic interpretation of these results. I'm sure he is. I'm sure he does. Write a statement relating your calculated probabilities to student enrollment in a given situation. So basically, it's saying, what does 82.6% mean? Well, always start with 82.6% of what? The condition. Key Club members. Of course, this whole situation is in the senior class. What about 82.6% of them? They are in AP Physics. So if you have to write a statement, start with the percentage of the condition is whatever it is. I'm making a video. He's welcome to join in for the video. Yeah. All right, we got another one of these crazy formulas that we've never seen before, and I'm sure they're going to tell us what everything means, and we're going to have to substitute in. Using the formula below, determine the monthly payment on a 5-year car loan with a monthly percentage rate of 0.625% for a car with an original cost of $21,000 and a $1,000 down payment. They are set. All right. Right now, I process none of that. I was waiting for this, and I was waiting for this. All right. It's telling me what each variable represents. So now I'm going to read back through that and see what's going on. It's asking for the monthly payment. So the monthly payment is PMT. That's what I'm trying to find. On a 5-year car loan. Well, I don't see years of the loan, but I do see monthly pay periods. If it's 5 years, it's 5 times 12, which is 60 pay periods. A monthly percentage rate of 0.625%. So that's 0.625%. To make that into a decimal, I'm going to have to divide that by 100, and that's going to become 0.00625. Whenever they give you a percent, you need to make it to a decimal divided by 100. The car cost $21,000 with a $1,000 down payment. So what that means is you have to determine how much the loan is for. If you're paying $1,000, you're subtracting $1,000 off, and you're coming up with $20,000. That's how much you're borrowing. The affordable monthly payment is $300 for the same time period. Oh, I'm not up to that yet. It's asking for the monthly payment. It's the nearest step. So P of M is the amount borrowed. That's $20,000. Equals PMT. That's your X. Parentheses 1 minus parentheses 1 plus 0.00625 to the power of negative n, which is 60, over I, which is 0.00625. So to solve this equation, the first thing I want to do is multiply by the denominator. So I'm going to go my personal calculator and do 20,000 times 0.00625, and I got 125 equals X parentheses 1 minus 1 plus 0.00625 to the power of negative 60. Now, all I have to do at this point to get it by itself is divide by this monstrous thing. So that's exactly what I'm going to do. I'm going to divide by 1 minus 1 plus 0.00625 to the negative 60. 1 minus 1 plus 0.00625 to the negative 60. I'm going to put that whole thing into my calculator. Make sure you're careful with the parentheses. Hopefully I don't make any mistakes. No promises. And I got X equal to the nearest cent, $400.76. Does that sound about right for a monthly payment? Yeah, that sounds right. Now, we have more. So I'm going to erase this, and I'm going to see what the next question is saying. So I'm just going to redo this because some of the variables might have changed in the second part of the question. The affordable monthly payment is $300 for the same time period. Determine an appropriate down payment. So the affordable monthly payment, that's your PMT. Oh, now my board's not working. Same time period, so N is still 60. The amount borrowed, well, that's what it's asking for now. The interest rate is still 0.00625, and it's asking for a down payment. Well, once I get the present amount borrowed, I can figure that out. So P of M is X, PMT is 300. 1 minus parentheses 1 plus 0.00625 parentheses to the negative 60 over 0.00625 625. Oops. So I can just put this whole thing into the calculator, and I do 300 times alpha y equals enter, 1 minus parentheses 1 plus I to the power of negative 60 over, what's not I? My I again is 0.00625 to the power of negative 60 over my denominator is 0.00625. And I got 14,971.5924. So that's how much the loan is going to be for. Correct. I'm going to round it at the end. Determine appropriate down payment. Well, if the car originally cost $21,000, I would need to do 21,000 minus the amount that I have to borrow, which is your 14,971.5925. I'm going to use that on my calculator. And I got $6,028, and to the nearest dollar that was asking is just that. Be careful you round the appropriate thing. That is a pretty high-level algebra question. Is that appropriate for a 10th, 11th grade high school student? No. But New York State can deal with that one when it wants to. 37 is fine. Last question, 6-point question. The speed of a tidal wave, f, in hundreds of miles per hour, can be modeled by the equation s equals radical t minus 2t plus 6, where t represents time from its origin in h hours. Okay, I've got a formula. S equals radical t minus 2t plus 6. Algebraically determine the time when s equals 0. Very straightforward. Except for the fact that board's not working. So I'm going to replace s with 0. And I need to solve this equation. What makes it different than a middle school equation? Well, the radical does. My first step in solving a radical equation is to isolate. So I'm going to add the 2t and subtract the 6 from both sides. Once I get that, I'm going to square both sides. Square and the radical cancel. My left-hand side, you can use square binomial theorem, but again, most students prefer the box, so we'll do the box. 2t minus 6, 2t minus 6, 4t squared minus 12t minus 12t plus 36. That gives me 4t squared minus 24t plus 36. Now, it's a quadratic equation because I have an x squared, so I bring everything over to one side. That's going to give me 4t squared minus 25t plus 36 equals 0. Now that everything is on one side, we want to factor. First, we look for factoring as a GCF. There is no GCF. It's not dot. It is a trinomial. Because there's something in front, I'm going to have to do my bridge method. Don't forget to pay the toll. If you do grouping, I do the bridge. First sign comes down, negative times a positive is a negative. What multiplies to 144 adds to 25? If you can't do that in your head, you can use your calculator to help you. It's 16 and 9. Before I say factor equal to 0, now I pay the toll. Divide by 4. If it divides nicely, divide them. If not, then the denominator comes in front. Try each factor equal to 0. So I'm going to have t minus 4 equals 0. and 4t minus 9 equals 0. Add 4, t equals 4, plus 9, 4t equals 9, divide by 4, divide by 4, t equals 2.25. Now, that's great and all, but in a radical equation, I must check. So I'm going to go back to the original, and I'm going to check each of those. So I'm going to do f equals radical, or not s equals, excuse me, 0 equals radical 4 minus 2 times 4 plus 6. And I'm going to do 0 equals radical 2.25 minus 2 times 2.25 plus 6. I can use my calculator to check them. This one will check. The other one, why don't we check it in my calculator right now? I have a feeling it's not. Radical 2.25 minus 2.2 times 2.25 plus 6. They are not equal. Therefore, 2.25 does not work, and t equals 4 is lots of yummy work. Of course, that's not enough for 6 points. I have another question, so I'm going to kind of restart this here and make some more space. It says, how much faster was the tidal wave traveling after 1 hour than after 3 hours? Well, it's easy. I'm just going to replace the t with 1. And I'm going to replace it with 3. I'm going to type this into the calculator. Actually, I don't even calculate for that one. That's going to be 1 minus 2 is negative 1. It's going to be 5. And for this one, I am going to use my calculator. And again, I'm not going to pull the one I have here. Nothing fancy by typing this in. I have 1.732. Not going to round it. So how much faster? 5 minus 1.732 is 3.26 whatever. It's asking for the nearest mile per hour, which is 3 miles per hour. Well, that was a long and fun journey we had together. We took a look at the part 1s. We used our multiple choice strategies whenever we possibly can. We learned how to solve our equations, make sure you're comfortable solving radical equations, fractional equations, exponential equations. Prepare for it. If you know how to do each type of question, you're going to be good. Again, watching this video alone is not going to get you to pass the exam. You must practice. Use the video for reference, but practice each type of problem. Once you prepare yourself, you should be fine for the exam. Hope this was helpful. We had some nice, interesting bumps and bruises along the way. But practice, practice, practice for your exam, and you should do fantastic. Peace out.